Now we are in the new venture of your subject, and already discussed about the sound waves in open organ pipe, and this interesting video lecturing with brief understanding of your subject is given by Fountain Coaching Institute. Since this is one of the summarizations of this chapter, so we need to provide all conceptual analysis of every topics. And in this particular topics, which is closed organ pipe, when sound wave passes through this closed organ pipe, what happens in these waves? Now before that, to understand what is concept of superposition of sound in the closed organ pipe, you must have to know the practical example of this closed organ pipe. The closed organ pipe, usually we see at the table, already I told you, different types of organic differences in your bodies. Sometimes whenever you are speaking something, that is your vibratory tunnel of your body is also used as a closed organ pipes. And the vibrating frequency, that means words, octave, pitch, loudness, tone, all things are coming by the different superposition of sound in this particular closed organ pipe. Now very interestingly, this is a very simple analysis of your subject. If a sound waves is propagating through this closed organ pipe, we know the air molecule inside this pipe has a greater pressure compared to the pressure in atmosphere. So air pressure inside is more than air pressure outside. Implies the pressure differences causes the reflecting sound waves, and sound waves will come like this way and reflecting like that way. So in a particular point when this reflection is taking place, this point will be considered as node, and where it is coming with the maximum pressure differences, then we call this an antinode. So at a node we get the pressure differences is minimum, but the amount of energy density is maximum. You know what is energy density? Question will come from this point. In IIT and PMT, you should know at the node energy density is maximum. Energy density implies the amount of sound energy for unit volume is providing to a point, and this is node point. And in this antinode point, the pressure difference is maximum, means energy density in this point will be minimum. Now since sound waves is coming like this way and going that, if the length of the pipe we are taking as L, so definitely we will get frequency of the system as we know V upon lambda, so that will be V upon, you see this is lambda by 4, so it is lambda by 4, this lambda is 4L, so V by 4L. I think you know this formula from your school syllabus. This frequency will called as fundamental frequency of first harmonic. So it is first harmonic of open organ pipe, sorry, closed organ pipe. And in this first harmonic, the fundamentals comes not beyond of that limit. If the length of the pipe is not sufficient to provide with a certain velocity of sound V at a particular frequency F, which is audible, then this pipe is not used as a closed octave pipes. Now if the sound superposed instead of single point, it comes 2 or more 3 points, like waves coming like this and going like that. Superposition takes one in reflecting point, other is the point of superposition. So in this particular case, you are observing the node is here is also node, here is antinode, and here is antinode. Implies you are getting 2 nodes and 2 antinodes. If the length of the pipe, as usual, we understand it is L, so this part is becoming lambda by 4, and that is lambda by 2. So lambda by 2 plus lambda by 4 will give you 3 lambda by 4. So L will be 4L by. So lambda can be written as 3 lambda by 4 can be written as your L. So definitely we can write down lambda is equal to 4L by 3. So in this situation, the frequency will be 3V by 4L. That means we are getting third harmonic, and you know whatever the second position of the frequency come, that is called overtone. So it is fast overtone. So you are getting third harmonic but fast overtone. In the next case, if we superimpose 3 times waves, you are getting 3 nodes and 3 antinode. And in this particular situation, we observe that if it is lambda by 2, it is lambda by 2, that is lambda, and it is lambda by 4, that is 5 lambda by 4. So L, length of the pipe, will be considered as 5 lambda by 4, means lambda become 4L by 5, implies frequency in this case is becoming 5V by 4L. Implies this is will give you 5th harmonic but second overtone, because it is coming on third point. Interestingly, whatever we are getting here, that first frequency is fundamental, which is V by 4L, has 1 node, 1 antinode. In the second case, we are getting frequencies 3V by 4L, that is third harmonic, and 2 nodes with 2 antinodes. In the third superposition, we are getting 3 antinodes and 3 nodes, and frequency become 5V by 4L. Implies all odd harmonics are coming. 1, 3, 5. But overtone, since it's a positional vector, so it is coming on 1, 2, 3. So in this particular situation, we can write that for a closed organ pipe, the frequency for the nth node or antinodes, since they are same in number, is 2n minus 1 V by 4L, where n is the number of node or number of antinode. And the frequency ratio, what we are getting is F1 is to F2 is to F3 for different node points or antinode points is 1 is to 3 is to 5 dot dot to n minus 1. So these are 2 points you should remember for your examinations. And another point is, interestingly, we have to discuss here that if it is varies with respect to the change of medium, such as in the first layer we are providing certain amount of gas, in the second layer we are providing with certain liquids or 2 different gases with different atomicity, such as one is monoatomic, other is diatomic, is filled in 2 layers. What will happen such frequency? IIT generate such questions from this very simple analysis. So closed organ pipe usually used to we find for the making of guitar, sitar, tanpura, you will say that one part is closed, other part you are vibrating each other. So in this particular situation, we will again discuss the application of closed organ pipe with the vibrating string. So next part I am coming for the superposition of the string waves, that is vibrating strings.